Today we are gonna do section 2.6. Let's see. So from today on, please, I'm not gonna finish some of the examples or homework, because to finish it just means that we have to solve basic equations, which it was done in section 2.1. So please review section 2.1 whenever necessary. That is to how to solve just the very basic equations. What I'm going to do in this course from now on is just to set up how each equation should be solved. And once we get to the solving basic equation point, then you are expected to finish that step, because that is a fundamental step and is extremely important to know it really well. That is section 2.1 part A, I believe, in fact. And so please review that section whenever you feel like you forgot how to solve basic equations. All right. And so having said that, let's look at page 150, where we consider example 1. Now first we will review the concept of exponents. This is back from chapter 1. That is, what is a to the power? First, let's consider the radical. What's the radical to the nth root of some number? The radical is also written as a fraction. That is just a habit. Everybody does that. Okay, so a radical is just a fraction. Now next, if you have say a to the power m times n, two things multiplied together, that's the same as you raise it to 1 of the power first, and then the whole thing raised to the next power. That is another rule we learned in chapter 1. So as a result of these two situations, say if you have a case where you have a to the power m divided by n, what does that mean? That based on this rule, it is the same as a to the power 1 over n to the power m. Okay, and so that is the principle that we learned in the first chapter. Well, actually it was a review from pre-Algebra, but I just want to refresh you this memory, because it's extremely easy to get confused or forget these rules. But once you remember them, they are very easy to apply. Okay, and I mean, it just means you split these things up and then do one fraction at a time. Or if you start here, you just take these two things multiplied together. So we'll keep this here, and you can refer to it anytime you feel like you forgot how that works. So let's then look at example 1. And what are we doing? We are trying to calculate a to the power 2/3. So we have a to the power, a to the power 2/3. Now, and what is that? We can just use the calculator to punch it out, which we could do, but first let's see if we can do it by hand, see how that works. Now, by this principle here, when you have a fraction that is the same as, you can do the fraction part first of the exponent, 3, okay, n equals to 3 in this case. And then raise it to the second power. Now, what is the 1/3 root of 8? That means you have to not divide 8, but think about 3 numbers. Okay, that's the third means. 3 numbers that when they multiply them by themselves together, they have to equal to 8. And it's very easy to forget that fact and think that you're doing division. You are not. You're taking the cubic root. So 3 numbers, what 3 numbers multiply by themselves equal to 8? Let's try 1. 1 times 1 times 1 is just 1, so we're getting nowhere. Try 2. 2 times 2 times 2 is 8. Okay, so our second attempt is successful. So a to the power 1/3 is just 2. Then 2 times 2, and now we just left with doing 2 squared, and that is equal to 4. And that is how this problem is solved. See, some of these problems can be done very quickly. Others might be quite tedious. So next, let's do a similar problem. That is x to the power 5/4, the same principle. So please do example 2 yourself. It is done identically to example 1. And of course, please do example 1 by yourself as well after the video. Now next, let's look at example 3, where there is a twist. There's always a twist. Okay, so example 3 says that we have something called 3x 3/4, and then equal to x 1/2. All right, now when you see all these weird looking exponents, and if you're don't feel familiar with them, please review chapter 1, where it's dealt with exponents in great detail until you refresh your memory concerning this matter. Now the way we solve this, being that there's x on each side, we're going to put them to one side. We have then 3x to the power 3/4 minus x to the power 1/4, 1/2. Why did I say quarter? So 1/2, and that will equal to 0. Okay, I just move that over. At this point, we will factor this out. What is the common factor when you have 1/2 and 3/4? What you have is 1/2. That is, if you pull out x to the power 1/2, what you have left here is x to the power 1/4. The reason is because when you multiply these two things together, the exponents add. Okay, and when you add 1/2 plus 1/4, it is 3/4. So that's that. Okay, next, when we pull out x to the power 1/2, there's nothing here left except 1. Because 1 times x to the 1/2 equals x to the 1/2. Okay, so that's what factoring does. Is when you multiply it out, it should come back to what we started with. Now that we have this, now what? Now we have the zero multiplication property. That is, if two things multiply equal to 0, one of them had better be 0. Okay, so we'll take turns. So first we have x to the power 1/2 equal to 0. That's the first solution, which just means x equal to 0. I mean, the square root of something is 0, that thing better be 0, right? And the second solution is x to the 1/4 minus 1 is equal to 0. Okay, and then we'll push the 1 to the other side, becomes positive. So then x is 1/4 is just equal to 1, and then what's x? X had better x then equal to 1. There's because so we raise everything. What we do is we raise everything to the 4th power, like this, to make x power 1. Okay, so 1 to the 4th power is still 1. Therefore, this is x and this is 1. Now, once we've done this, we have to quickly check to see this actually works, because we're raising stuff to the 4th power, and when that happens, you can sometimes introduce fake answers that suits here, but not the original solution. So let's see, if x is 0, does this equal to 0? Yes, definitely. Now what if x is 1? That will be 3 minus 1, that's just 2. Now let me check. Oh no, I knew there was something odd. I forgot my 3 when I factored this out. See, what happened to the 3? We need the 3. So let's add the 3 here. That's much better. Yeah, so we have a 3 here. Okay, so then this line doesn't work. Let me erase that. So let's try again. Now this time, make sure you don't miss the 3 like I did. Okay, for no reason too. It was right there. And anyway, so this is the second option where it equal to 0. That means we have x to the 1/4. This is still x to the 1/4 will be equal to push the 1 over here and then divided by 3. And it will be equal to 1/3. So we are gonna, being that this is x to the 1/4, we will raise it to the 4th power, because as we have said that, we'll do the same thing here. As we have said, this times that is how that works, okay? When you have something like in this situation, you just multiply them together. And I want x to be power 1. So if it's 1/4, then I have to multiply by 4 to become 1. So this side has to be multiplied by 4 as well. And that gives us, that will give us x. And this side will be 1/3 to the power 4th. You can write it this way, okay? Because because that is the same as 1 is also to the power 4th, which is just 1. I should write down that idea. That is, if you have a fraction over b to some kind of power m, this is the same as a to the m divided by b to the m. That's another rule from chapter 1. So anyway, so now we are good. Now if x is one of our first solution is x equal to 0, which we did confirm that does work, right? Is the 0 to minus 0 is 0. Now what if x is this thing? And we have to actually make sure that it does work. So we need to plug this thing in there. The reason it might or might not work is because we raised this thing by the 4th power. And when that happens, weird things can happen, I guess. Although in this case it should work though. Well, anyway, let me check to see if I made another mistake. No, it's fine. This is just 1 over 81. That's good enough for anybody. Okay, we'll just stop right here. And because we have directly solved that this thing equals to 1 over 3/4, so it will work. So that's the end of, what's that, example 3. All right, now generally speaking, we are going to solve equations with factoring if we can, because factoring is usually the easiest solution, but factoring doesn't always work. Okay, it's just like solving quadratic equations. Factoring doesn't always even carry out, and we need a quadratic formula. In other polynomials, the same idea applies. Now let's look at the next page. We are now on page 152. 152. And then let's look at example 4, where we have example 4. Okay, we have, what is that? 5x squared. No, 4th. 5x to the power 4th. X to the power 4th equal to something, 80x squared. All right, so there's our problem, and as always, we're going to solve this thing by, well, let's move everything to one side. So we have 5x to the power 4th minus 80x x squared, that equals to 0. And the first thing we do is factor something out. That has an x squared as a common factors, and 5 also, so we'll take both out. So we'll take 5x squared, the common factors, which leave us x squared, and that is 80 divided by 5, that's what? Maybe 16 or something. And yeah, there's 16. You can use your calculator to confirm it. Yeah, I think so. And so then we have these two things. First, the first term so we have two things that multiply to be 0, and then one of them had better be 0. Okay, so our options are 5x squared equal to 0, and then that gives us just, well, then that's just x equal to 0. There's no other way that's going to happen. And then the second option is x squared minus 16 equal to 0. And so x squared is going to be equal to 16, which means x is equal to the square root of 16 plus or minus, okay? Plus or minus 4. That means this is just another way of saying x equal to 4 and x equal to minus 4 as part of the solution. So there are 3 possible solutions: x equal to 0, and 4, and negative 4. And your book mentions that 0 is a double solution. That's because x was 0. If you factor this, there's 2 x's both equal to 0. But we will, yeah, not worry too much about that, and let's move on. Okay, that's example 4. Next, let's look at example 5. Well, we'll actually, before example 4, we'll look at we'll look at its graph briefly. If you were to plot this example 4 in the graphics calculator, or better yet, if you just type it into the Desmos graphics calculator, which is much better, and you will see the graph that looks something like this. What happens is for the x is that it hits plus or minus 4 on each side, okay, and it barely touches 0. Then it turns back again. So the double roots, when it's 0 twice, because of the squared here, usually have that quality of being touching. Instead of crossing, they touch. And it's just a cute little situation. Now notice that the y thing it goes all the way up to 500, whereas x only goes to plus or minus 5, right? The reason for that is if you don't do that, if you don't change the ends, then your graph will, you can, but then your graph, you won't be able to see very much of it. Then your graph, so the whole graph is being squashed. And otherwise it just is not near as big. That's because the numbers here are really, really big. So the graph is going very fast. So if you do plot this thing, you will see why they squashed all the way down to 500 so that you can see the graph at a reasonable level. And so anyway, so let's move on. Okay, for now, and I just want to quickly mention that. We'll talk about that some other time too, how to graph things. But for now, we are focusing on solving the equations. And so let's move on to example 5. And of course, please do example 4 and all the others as part of your homework. Then let's consider then example 5. And now example 5 is quite a bit harder. Okay, and what we're going to do is, here's the third power thing, and we're supposed to somehow factor this thing. And so we're going to do it by trial and error and hope for the best, is how you solve this kind of stuff. And so 3 minus 9x minus 9. So we're going to solve this thing by factoring, which is okay. Okay, how are we going to factor that? Luckily, this is an extremely simple example where we have 1, 1, okay, and then 9, 9. So they are very, very similar. So we can group it like this. And that will equal to 0. What I mean by that is this will be our first group, and that will be our second group. So let's group this thing and factor it. So this group, when we factor it, will become x squared, because this group has x cubed and x squared. So we take out x squared as its common factor of just these two things. Okay, so then we have x plus 1 left. And as you can check quickly, this multiply becomes that. So this multiply this becomes that. So we're good. And the second group, we're going to factor out the entire negative 9. That is, we're going to factor out the negative sign as well. So then what we have left is just x, okay, because minus 9 times x is minus 9x. And secondly, we're going to multiply that is, going to factor that out. That gives us positive 1. Being that positive 1 times negative 9 is negative 9. All right, so this is a very simple, quick, lucky problem where everything is set up very nicely for you, okay? And so now we look at it and check this. It has a second common factor. How did that happen? Well, by luck, again, it just happened to work out this way. They're not always going to be this nice, as you can imagine. But for now, we are in the lucky mode, okay? So we are going to enjoy our luck while it lasts. So here's our luck. This is a common factor for both terms. Okay, here's a term, here's another term. They have a common factor of x plus 1. We can therefore take it out, the entire x plus 1 as a common factor. And that gives us x squared minus 9 as what's left. So x squared is left from here, and minus 9 is left from the second one. So then we equal to 0. And then x squared minus 9 is the good old perfect square difference of squares. Okay, and I'll write that again. It seems like I write this every time. A squared minus b squared equals to a plus b times a minus b. This is something that you need to memorize or just learn it as part of your being. Okay, in part of your algebra being is this shows up a lot. So this thing then becomes x plus 1, that stays here, okay? And factoring this thing according to that principle, it will become the plus and the minus option. So that will become x plus 3, okay, because the square root of 9 is 3, and then x minus 3. So now our solution to this thing has 3 answers. So therefore x is equal to, this gives us x plus 1 equal to 0. That's x minus 1, okay, when you push the 1 to the other side of the equation. X plus 3 equal to 0. That gives us x equal to minus 3. In general, you just flip the sign of this thing. And then finally, x minus 3 equal to 0. It gives us x equal to plus 3, okay? And there it is. So that's our 3 solutions. Is that what the book says? 3 minus 3 and 1. Yep, that's correct. Now the book does give us the graph of this thing, so I want to talk about the graph briefly. Now being this is a cubic power, the graph always look like this, and then as you can see, it hit three points. Okay, now very nicely. So it's a nice little problem, and it hits the x-axis at 3 dots, as you can see, and those are the solutions. Whenever your graph, that is this thing just here, hits the x-axis, that's when it equals to 0. Okay, because this is the y value, and when it equals to 0, it will hit the x-axis. So another way of finding a solution of some function like this is simply just graph and see where it hits. And that is another way of solving an equation. But we're not going to talk about that right now, okay? We'll talk about that later in much more painful detail. Anyway, so let me clean off the board. So please do example 5 as part of your homework. And then we're going to look at example 6. Now, example 6, we have an equation with a radical in it. So let's look at this thing. Here's a radical, 15 times, I don't know why it's called radical. The word radical might come from the word root, is why. Okay, anyway, so we have this situation, okay, square root of 15 minus 2x equal to x. That just means you need to dream up some number where 15 minus the 2 times that number equals the number itself. Now, off the top of my head, I would say if we try 1, that's not going to work. What about 2? 2 times 2 is 4. 15 minus 4 is what? No, that's not going to happen. What about 3? If it's 3, 2 times 3 is 6. 15 minus 6 is 9. And that would work, wouldn't it? So x equals to 3. I'm just guessing off the top of my head. Okay, x equals 3, I believe, will work. Yeah, if you check it, it will work. However, in general, we're not going to do the guess job because that's really tedious and it'll take forever. It's better to just solve it because x might not be a whole number like 3. What if it's 2.5 or something? Then I'll never guess it. So we're going to do that. But I just did a quick guess job to show you how these problems come from. Or the easy ones, you can't just guess, okay? But anyway, this happens to be an easy one, so let's work it the regular way. So the way you do this is whenever you see a radical sign, the very first thing you do is get rid of it if you can. Because we humans don't like radical signs. We want to get rid of it. So you get rid of radical signs by overcoming the power. Being that this is a square root, we'll square it, okay? And so then we have to square a square root, we'll get rid of it. So we'll square, and we'll square both sides to be fair to the equal sign. So now we have this situation, okay? And then we are going to write this as write everything that in the side of the highest x power. So we have this thing, x squared plus 2x, and then minus 15, right? And this side will be 0. I moved everything here. And then we solve for x, and x will be equal to 2 things, and then equal to 0. Now, so what would that be? That would be x. Let's do this trick from, I don't know, section 2.1 or something. And we need 15, and then need to be a plus. So it will be plus 5, okay, to end up with a plus 2, and minus 3. 3 times 5 is 15. And that's about it. So then the solution is x equal to 3, as we guessed earlier, right? And then this part becomes x equal to negative 5. So the plus 5 becomes minus in the solution. Push it to the other side of the equal sign. So we have 2 possibilities, x equal to 3 and x equal to negative 5. Now x equal to negative 5 is rejected. The reason is because the square root is positive, okay? So no way is the square root going to be negative, so this is rejected. Reject. No, can't say that because then you think I'm writing about x. So this solution is is rejected, right? So this is the only one that we choose. This one is let's just say is crossed out. So that's the only answer that we can accept. because the square root cannot be equal to a negative number. Okay, it's that simple. If the question isn't that easy, we might have to plug the whole thing in to see if it equals to both sides. Either way, that is well, that's how we do things. So you might wonder, how did we end up with something that doesn't even work? The reason is because we square things. Whenever you square things, there's a chance of introducing fake solutions. What does your book call it? Extraneous solutions. That's what it's called, I believe. Yeah, extraneous. Whatever word you use, the point is it doesn't work. Okay, so we have to reject it. But 3 does work, and that's the only solution to this equation. So please do example 6 as part of your homework, and then we are going to move on to example 7 on the following page. So next, let's consider example 7, which we have the problem says we have 2x, oops. Okay, now example 7, we have come to the painful part of doing algebra. I have what's so painful about it? To me, the problem is you have 2 radical signs. Now, even when you deal with something painful, let's just buckle down and show our determination and beat it up anyway. Okay, because there's two of them, so life is more complicated than if there were only one. So the way we do 2 radicals, equation like this, is first we put the radicals on one. We'll put the other radical on one side so that there's only one radical on one side at a time. So let's do that. So we rewrite this thing. This will become 2x plus 3. It will be equal to 4. We'll put the second one to the other side. No reason, somebody has to go to the other side. Okay, so 4 minus, when it goes to the other side, so change the sign to, in this case, negative. We have x minus 2. And then at this point, we're going to square both sides, just like this one. Okay, and that doesn't sound so bad yet. So let's do that. So this is 2x plus 3. Right? The square of square root is just the thing itself. Now this side is a different solution. We have, this is, what is that? This is 4 minus square root of x minus 2. And this whole thing has to be squared. Now, what is this whole thing squared? We have to multiply this out like any other square. Okay? And so let's do that here. What is 4 minus square root of x minus 2 and the whole thing squared? The way we do it is the same way we always do it. That is, what is the square of a plus b? A plus b squared is equal to a squared, okay, plus 2ab plus b squared. You can do this. This is true because if you work it out, that's how it comes. Okay, you have a times b, a squared, then a times b twice, and then b squared. Or you just multiply it out the old-fashioned way. Either way, that's the fact. Now, to apply this formula, or just multiply it out yourself, either way, you're going to end up with 4 squared, that's 16, okay, minus 2 times 4 times the square root of x minus 2, because that's the b, basically. Okay, this is b and this is a in this formula. And then plus the b squared. B squared is just x minus 2. So that equals to the whole thing. I don't need the parentheses here. All right, so that is this whole deal, which we are going to write this thing down here. With one thing is there's 16 and minus 2, so that becomes 14. All right, so that equals to, I'll write that thing over here, okay? That equals to, I'll write it, yeah, equal to 14, being the 16 minus 2 at the end, minus 8 square root of x minus 2, and then plus x, right? So that's what that becomes. All right. So continuing, so far we're so good. We have plus x on this side. We'll move it to the other side. It becomes minus x. So we have 1x left. So x, so we have x, x plus 3 on the one side is equal to x plus 3 and then minus 14, okay? Minus 14 is going to be equal to this stuff, which is negative 8 square root of x minus 2. Okay, now so the plus 3 minus 14 is 11, so we have x minus 11 here. And now we're going to do the painful part, which is we have to square both sides again, okay? Because we have 2 square roots, we have to square both sides 2 times. And which sounds like a lot of work, and it is, but we have to get this done, okay? There's no getting out of it. So we have x, we'll square both sides, so this thing's being squared, and this thing is also being squared. Minus 8 square root of x minus 2. Okay, so now we're just gonna buckle down and do some grunt work. And this becomes, let's multiply this thing out, okay? So this becomes x squared minus 11 times 2. Applying this formula except with the minus sign is to become 22x plus 11 squared. That's 121. All right. And then this side, it becomes 64 times x minus 2. Okay, because the square root takes care of it, so we're squaring 8, and then it becomes 64, and then this thing squared is just x minus 2. All right, so far so good. Now we are left with something that we need to clean up. This is in x squared. So we have minus 22. I'll write this. Wait a second. I will write this down. Let's move everything to this side of the equation. So we have x squared minus 22x minus 64, and then plus 121, and then this is a minus, okay, minus 64 times 2, and then we'll move it over here, it becomes a plus. It plus 64 times 2. Okay, and that should be equal to 0. See, I moved everything to this side of the equation. This step looks a bit annoying, right? With big numbers and stuff, but it's the same process. We haven't, so with the help of a calculator, if necessary, you can totally do this. So that equals to, we'll write it one more time. So x squared minus 22x. So there is do this stuff. This is, what is that? That is 121. This is minus, this is equal to 121 minus, minus 64, okay? Let's do this trick, okay? That's, I don't even remember how to do this. That is 5, right? And that becomes 11 minus 6 is, isn't that also 5? No, I don't think so. 11 minus 4 is not 5. 11 minus 4 is 7. Is that better? That looks a bit better, right? And then, so what is that? That is positive and then negative. So it's a positive number, 57, equal to 0. Sorry, I made another mistake. This 64 is times x, right? Where's my 64 times x? Yeah, right here. I forgot the x. So this part is not correct. Okay, let me get rid of that. Now let's try again. Okay, so I got put the x back, and let's do this. Now we have minus 22 minus 64 x, and so that becomes 8 and 6, right? X, and then the numbers becomes 121 plus 2 times 64, that's 128. That should be 249, right? Is that right? Oh, I better not have made another mistake. Yep, it is correct, finally. I knew I was going to mess up in this mess. That's why I don't like doing this. I mess up a lot. But anyways, but that's why it's important to do it according to the example, because then if you mess up, then you can catch it right away, okay? Instead of getting all the way to the end and don't know where you messed up. Ugh. Anyway, so anyway, we're going to factor this thing out. And how are we going to factor this thing out? That is, we're going to use something called the quadratic formula, okay, which I asked you to memorize last time. What is the quadratic formula? It is x equals to minus b minus this thing, 84, 86, which becomes positive, plus or minus square root of b squared times 4ac, okay? So we have b squared. Although, I guess in this problem, we can skip that. Let's skip the quadratic equation. Well, the reason I want to skip this is, let's say, let's try factoring a little bit, being that this has only coefficient of 1, so we might get away with it. If not, then we're going to have to use the quadratic equation. So, being that this is just 1, that makes life a bit easier. And that number is 2 plus 4 is 6, okay? 6 plus 9 is 15, which means this number is divisible by 3. And then there's a rule in grade school that says if all the digits add up to be divisible by 3, then the number itself is also divisible by 3. So we'll divide it by 3, okay? And what happens when I divide by 3? That would be 6. What am I talking about? Divide by 3 is 8, right? Is 8 and 3. And 8 and 3 together, we have 83 plus 3 is 86. So we can do this. So this is somewhat faster than the quadratic formula. Well, just because we also lucked out, okay? What if this at 87? Then we're out of luck and have to pull out the formula. But anyway, so our two solutions for this case is x equal to 3 or x equal to 83. Okay, and what have we been doing this whole time? We are still trying to solve equations, problem 7. So x equal to 3 or x equal to 83. I don't know how that's going to come out. So the 83 looks a bit big for our stuff, so it might not work. But 3 probably will work. So let's plug it in and see if it works. Okay, first let's consider the 3. When x is 3, 2 times 3 is 6, plus 3 is 9. That will give us 3 here, right? X equal to 3. 3 minus 2 is 1. Square root of 1 is 1. So plus equal to 4. So x equal to 3 definitely works. Next, let's try 83. 2 times 83 is 160 something. And plus 3 is something else, right? And so by maybe 170 or so, you take the square root of 170, that gives us what? I don't know. It's more than 11, right? Because 11 squared is 100, is already 121. Then plus some is more than 11, then plus something is not going to be equal to 4, because this thing is negative. I mean, this thing is positive, sorry. So we have, or you can just plug the whole thing in and see what happens. But anyway, just by a quick calculation, you know that the 83 is not going to happen, okay? It's too big, because the two roots are being added, and they're both positive. So, and they can't be 4 when you are starting out with 83. But either way, or you just plug it in with a calculator, either way, the 83 answer had better be rejected. And so that is, so as a result, x equal to 3 is the only solution to our problem, which is, yeah, it's, to me, it's always been painful to do this kind of thing. You know, you have 2 square roots, which I was very resentful of being forced to do it. But there's a time in life that you have to do something that's unpleasant, okay, in all hobbies. Because the reason is so that when you go back to the easy problems again, then you truly can appreciate how nice they are. All right, so please do example 7 as part of your homework. Even though it is rather annoying, please do it, okay? And I will erase the board. Now let's next do example 8, the absolute value equations. Now what was the absolute value again? The absolute value of a number, say x, is just equal to the number that without a sign. That is, we slap it into positive. As an example, let's consider absolute value of 4. Okay, that is just 4 because it's that is just 4 because it's already positive, so we don't have to do anything in terms of absolute value. The trick comes is when it's negative 4. If it's negative 4, well, it becomes 4 again. Okay, and then you just get rid of the negative sign, which means the absolute value of a negative number is actually equal to the negative of the x, because when x equal to 4, I mean minus 4, see? Because when x is a negative number, such as negative 4, then negative x is equal to 4, right? Negative x equal to 4. And that's why this equation is true for x less than 0. And whereas this equation, this x absolute value is just equal to the number itself if x is bigger than 0. So these are the two conditions for absolute values. Okay, and so they might look a bit cryptic because you have two conditions, but if you consider an example, then you see why that would make sense. And so knowing this is all we need to do example 8. Let's look at example 8, part A, where we have 6x plus 4 in absolute value has to equal to 8. Now, so as always in absolute value, there are two conditions. The first condition is if the stuff in here is bigger than 0. So let's write that down. So we have 6x plus 4 is bigger than 0. Okay, in this case, then the inside is, we don't change it. Okay, so the absolute value is just equal to x itself, right? When it's inside is positive, so 6x plus 4 equal to 8. And then we can solve this equation quickly. So 6x equal to 6x will be equal to 8 minus 4, which is 4. So gives us x equal to 4/6 or 3/4. So that is the answer. All right. So I mean, what did I say? 2/3. Sorry. So x equal to 2/3, which is fine. So that's if this is bigger than 0. There's another possibility. What if this thing is less than 0? So if 6x plus 4 is less than 0, oops, where's my less than? If it's less than 0, and do we say less than or less than equal to? Well, anyway, if it's less than 0, let's just think of that. And then let's say this equation stands again. And then this equation, then we have to slap a negative sign on there, okay? When that is the absolute value of x equal to negative x if the value inside the absolute value is less than 0. So assuming this whole thing is less than 0, then we have to slap a negative sign in front of the entire 6x plus 4. And that will be equal, that's less than 0, equals to 8, right? And then we have, then we solve this equation the same way. So we have minus 6x, and the minus sign goes all the way through, minus 4 equals to 8. And then we have minus 6x equals to 4, okay? So then x will be equal to, become a negative 4/6, or 3/2. So that should be the second solution. Did I get this wrong? Give me a second. Let me check. See, I made this mistake right here. When minus 4 pushed to the other side, it should be plus 4, right? So there should be 12. It's 8 plus 4, not minus. Anyway, so that should be 12. So then x then equal to 12 divided by negative 6, which is minus 2, right? Yep. That is a far better answer. So see, that will be the second answer for this thing. Okay, now then next let's look at problem part B. Part B says the absolute value equals to, of something. Okay, let's look at part B. It says the absolute value of this thing equals to -9. Now when you look at that, then you immediately know that no way is absolute value going to be negative number, because absolute value is defined to be always positive, right? Absolute value of positive number is itself. Absolute value of a negative number is throwing away its negative sign, okay, and it's itself without a negative sign. So there is no way the absolute value of anything going to be negative 9. So there is no solution to that problem, and that's the answer. Okay, the answer is no solution, period. And then, so next, let's look at problem C, where you have 3x minus 5, then minus 4 equal to 6. So what you do is just push the minus 4 to the other side, right? So it becomes 6 plus 4. And at that point, it becomes 3x minus 5 equal to 10. So then it becomes identical in format as a problem part A. You just have to throw the 4 over, and then you solve it just like part A. So please do that as part of your homework. And finally, this thing equal to 0, when the absolute value equal to 0, that just means the thing itself equals to plus or minus 0, which is still 0. So minus 5x plus 10 is 0, period. Okay, and when it equals to 0, then x is equal to 2, right? If you do the math in your head, minus 5 times 2 plus 10 is 0. So x should be 2, and that's your only answer. So please do example 8 as part of your homework. And then we will move on to the next page. Now I will finish this section in the next video. So in the next video, we will continue at page 158 and continue with example 9.